All right, guys, on this homework, this is ridiculously easy compared to what we've been doing already. They want us to find the Y-intercept of each and every one of 1 through 3. They want us to find the axis of symmetry, which is simply the equation x equals the x value of your vertex, and also the x coordinate of the vertex, which is done with the formula, x equals negative b over 2a. It also says make a table of values that includes the vertex. So they want you to make an input-output table and also include that x value of your vertex that you got from the vertex formula. And then it says use this information to graph the function. So let's first walk you through this, especially because if you look at the answers on the back, they do things slightly differently than what we do. Let's begin by finding the vertex. So everybody jot down, and you're probably going to have to write really small or maybe even in your notebook itself. To find the vertex, you're going to use the vertex formula, x equals negative b over 2 times a. And when you use that formula, use parentheses instead of the b and the a. And of course, we know that the a value is 1, the b value is negative 8, and the c value is 15, but we don't even care about that because there is no c in the formula. So the b value is negative 8, the a value is 1. So what we really have is positive 8 over 2. So the x is really positive 8 over 2, which is really 4. So the x value of the vertex is 4. Now, notice that the instructions didn't say find the complete vertex, even though that's what we're going to need to do anyway. They just say find the x value of the vertex. So for right now, normally, I would plug in 4 and work it out to find out what my y value is, but I'm just going to hold off on that for a moment because they're not asking for it. What are they asking for? Let's go back to the instructions. It says find the y-intercept. Let's begin with that, finding the y-intercept. I hope we remember that finding the y-intercept is the easiest thing in the world. All you have to do is set x equal to 0 and solve. And when you do the y-intercept of a standard form quadratic trinomial equation, that's the easiest thing in the world because when you plug in 0 right here and right here, what's your answer? Your c value, 15. So the y-intercept is 15 just by looking at it. That's the y-intercept. Okay, so that's the first answer that they want us to write. And what else? The equation of the axis of symmetry. All right, so let's write down axis of symmetry equation, A of S. We said that that's always going to be the equation x equals the x value of our vertex. And we found the x value of our vertex over here using the formula. So that's 4. So the axis of symmetry equation is x equals 4. I always draw that in green whenever I graph. Axis of symmetry equation is x equals 4. What else? It asks for the x coordinate of the vertex. We already stated that. The x coordinate of the vertex is 4. Moving on to part B, it says make a table of values that include the vertex. Now this is where you might get confused when you look at the answers, because on the back they do their table, and I always make my table like this, input, output, x, y. And on the back they do it horizontally, and they put the x up on top and the y on the bottom, like this. But not only that, they also don't even write y. Instead of y, they write f of x, which is totally fine, because f of x is the same thing as y. So what I say is stick to what you're comfortable with, which is probably the xy table that we always worked with, vertical, up and down. Okay, so we want to plug in some numbers into this input-output table to be able to get out some answers, to be able to graph coordinates, right? So they say use your vertex. The vertex x value is 4. Plug it in into your xy table. That way we could say, okay, plug in 4. That way we could find the y value, the output. So when I do plug in 4 into the x squared and the x right there, like I said, you're probably going to need more space somewhere. I'm going to just rewrite it right here. F of x equals x squared minus 8x plus 15, and I am plugging in the 4 of my vertex x value to find the vertex y value. So doing the math, 4 squared is 16. 8 times 4 is 32. Bring down 15. When I go 16, take away 32, that's negative 16. Negative 16 plus 15, that is negative 1. So my vertex, my most important point, 4, the y value would be negative 1. So now that I know that most important point, 4, negative 1, I'm going to graph it. So 4, negative 1. Now here's the problem, guys. if we go by 1 unit values, it's not going to work, okay? Because if I go to 4, -1, well, actually, 4, -1, 1, 2, 3, 4, -1. Don't jot this down, right? Just watch me do this, because I don't think it's going to work. I draw my axis of symmetry through here, and if I wanted to show my, yeah, it'll work. It'll work. Let's do it. Copy it down. I mean, you're not going to be able to show your Y-intercept, right? We said that the Y-intercept was 15. 15 is going to be way off the graph, but that's okay. We're just going to draw our parabola right here. Now, we know that the A value is 1, so we know that you could go with the pattern 1 over 1 up, 2 over 4 up, 3 over 9 up. And that's totally fine, and you could do that whenever you want. But right here, they want you to practice using an input-output table and plugging in 2 numbers that are on the same side of that axis of symmetry, x value. Okay, so what 2 numbers would you like to plug in? Actually, what side would you like to use, the left side or the right side? Left side. Excellent choice, left side. So on the left side, pick 2 numbers that are close to this axis of symmetry, which is x equals 4. It'd be a good idea to plug in 3 and 2. So let's plug in 3 and 2. Let's plug in 3 for x and also 2 for x. So when I plug in 3 into my x's, okay, this is going to be, I want to do this in my head because I'm running out of space here. 3 squared is 9. 8 times 3 is 24. 9 minus 24 is negative 15. And then negative 15 plus 15 would be 0. Maybe it's not a good idea to do it in your head. Anyway, 3, 0 is a coordinate. 1, 2, 3, 0. Put a dot right there. And then plug in 2. If you plug in 2 right here and 2 right there, 2 squared is 4. 8 times 2 is 16. 2 minus 16 is minus 14. Then minus 14 plus 15 is 1. So when I plug in a 2, I get out a 1. Let's go to the coordinate 1, 2, 1. That did not work. I messed up, didn't I?
Yeah, you said 2.
Okay, so that was a perfect example of why you should not do math in your head, okay? Because you make mistakes just like I did right there. Let me actually show my work. So here's my function, x squared minus 8x plus 15 with parentheses instead of x's. Now let me plug in the 2 right in there. So I'll have a 2 there and a 2 there. That'll be 4 minus 16 plus 15. So yeah, it's going to be 4 minus 1. It's going to be 3. So when I plug in a 2, I get out a 3. Now let's graph that coordinate 2, 3. 1, 2 on the x, 1, 2, 3 on the y. There it is. All you have to do is map them over to the other side of your axis of symmetry, and you have yourself a parabola. Now, the parabola obviously took a ridiculous amount of time because we used the input-output table, and it would have been a lot easier, a lot faster using the pattern 1, 1, 2, 4, 3, 9. Now, the worksheet wants you to practice using an XY table, but at this point, I'm like, whatever. If you guys want to use a pattern, go for it. Okay? So from the vertex, you could have gone 1 over, 1 up to get to that blue dot. You could have gone back to the vertex, 2 over, 1, 2, 3, 4 up. You could have even gone back to the vertex and gone 1, 2, 3 over, and 1, 2, 3, 4, 5, 6, 7, 8, 9 up to make that parabola even further and better. You could have mapped that over to the other side as well. So you could have extended your parabola even further and make it better using the pattern. So the pattern's great. They also asked you to state the domain and range on these. Oh man, I just messed this up, didn't I? So, oh, they don't ask for domain and range. I guess that's it. Okay. So 1, 2, and 3 are easy. All you have to do is graph it. And if you want, use a pattern instead of the table. Down here, this middle section, determine whether each function has a maximum or minimum value, and then find that value. Okay, let's look at number 4. What could you tell me about this parabola? Does it open up or down? It opens up because the a value is positive, right? This a value is positive 1. So we know that it's opening up. Now, what does that tell you about this vertex? That's a minimum value. Okay, so we're going to write down it's a minimum. Now, we need to find that minimum value. So minimum value at, and what's my answer going to be? How do I find the minimum value? if I'm looking for this lowest point of a parabola, what am I really looking for when it comes to algebra? The vertex, exactly right. So let's find that vertex by doing x equals negative b over 2 times a. When you use that formula, use parentheses. The b value is 2, the a value is 1. So you put a 2 right there and a 1 right there. So you end up with negative 2 over 2, which means negative 1 is the x value of your vertex. So the vertex has the x value of negative 1. And we need to find the y value, so we just need to take this x value negative 1 and plug it in right here and right here. So take the x values and plug them in. The x value negative 1. So I want to rewrite my function. Instead of x squared, I put parentheses squared plus 2x plus 2 times parentheses minus 8. And let's plug in that negative 1 into those x positions. And let's do the math. Negative 1 squared, that's positive 1. 2 times negative 1 is negative 2. Bring down the minus 8. So you really end up with negative 9 as your y value of your vertex. So determine whether each function has a maximum or minimum. We already said it was a minimum because it opens up. Then it says find that value. That minimum value is negative 9. So it's a minimum value at negative 9. What else do they ask? State the domain and range. That's easy. The domain of any parabola is going to be x equals all real numbers. And the range is going to be y is either greater than or equal to or less than or equal to, depending on your parabola, if it's opening up or down. So what would we say? First of all, let me write down the domain here. We said x equals all real numbers. That's the same for all parabolas. The range is going to be what? Y is greater than or equal to, because the parabola is opening up. And it has to be greater than or equal to that lowest point of the parabola, which we said was a minimum value of negative 9. Okay. So that's what we're doing for that middle section. And we do want to answer number 10. It says from 4 feet above a swimming pool, Susan throws a ball upwards with the velocity of 32 feet per second. The height h of t of the ball t seconds after Susan throws it is given by the quadratic equation h of t, which is negative 16t squared plus 32t plus 4 for t is greater than or equal to 0. It sounds crazy, right? All you have to do is find the maximum height reached by that ball. So algebraically, what are they asking you to do with this quadratic trinomial function? Find the vertex y value, to be more specific. So you could do that one by using the formula, x equals negative b over 2a. Then you plug in, oh yeah, by the way, instead of x's, it's t's, right? So I guess you could say t equals negative b over 2a, and then plug in your t value to find out that max height. Okay, so ladies and gentlemen, I've already explained other questions on this worksheet in other classes. Right now I want you to jump to number 2, and we want to answer everything that they want us to answer up here. We want to state the y-intercept. That's what they're asking for on part A. Find the y-intercept. So everybody, let's either write in your notebook or write very tiny. You need a lot of space here. So y-intercept is, what's the y-intercept? Well, we need to find the y-intercept. How do we do that? Do you guys remember how to find the y-intercept? Set x equal to 0. All right, that's something that we need to know. The y-intercept, you set x equal to 0. So that's really easy to do when you have a quadratic trinomial equation. Put the x is equal to 0, which means that your c value will be the y-intercept. So what's the y-intercept? It is 12. So the y-intercept is 12. Y-int is 12. Man, that is really disgusting. I hope you show better answers than that. But your y-intercept is 12, right? It's going to cross your y-axis at 12. Now, before we even move on to other things, if we look at the graph they provide us, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, man, you're not even going to be able to see that y-intercept. So because of that fact, let's adjust our units by 2. We'll make our y value units be by 2. So how about this? Let's put a little tiny 2 right here, a 4. See what I'm saying? An 8. No, not an 8, a 6. An 8, a 10, a 12. That way we will be able to see that y-intercept. A 14 right here. Right, really tiny. And that's what they do on the answer sheet on the back side. All right, so if you look at the backside, it's not going to make sense unless you actually go by 2's on your y values. Anyway, let's continue with the instructions here. It says find the y-intercept. We already did that. It says write the equation of the axis of symmetry. Well, in order for me to write the equation of the axis of symmetry, I need my vertex, at least my vertex x value, because the axis of symmetry equation is the vertex x value. So let's all do this. Let's put v for vertex, and let's find that vertex using the vertex formula. X equals negative b over 2 times a. And when you do use a formula, let's use parentheses instead of the b and the a. And let's label our b value is negative 4. Our a value is negative 1. So you really have a negative 4 up here in the parentheses in place of b. We have negative 1 in the parentheses in place of a. And of course, up on top, a minus negative changes to plus plus. So we will end up with positive 4 over negative 2, which means that our answer is negative 2. But what does that answer actually mean? What is that answer? This is our x value. So this is our x value of our vertex. So our vertex x value is negative 2. We still need the y value. Now we could find the y value because we know we're going to need it anyway. Or we could hold off on it till they ask us to do it on the instructions. Let's just find it anyway, right? So how do we find the y value when we already know the x? We plug it in. So I am going to rewrite this quadratic trinomial right here exactly the way it is, but instead of x's, I want to put parentheses. So I want to put negative parentheses squared instead of negative x squared minus 4x minus 4 parentheses plus 12. And I'm going to plug in this x value of negative 2 that we found with the vertex formula. So the x value is negative 2. Plug it in place of x. Let's do some math. Do not, I repeat, do not change these minus minus to plus plus. That'd be incorrect. You have to do exponents first before a negative times a negative. So exponents first, that's negative 2 squared. That is positive 4, but you bring that negative down in front of it. That'd be a negative 4. And then we do some multiplication over here. Negative 4 times negative 2, that's positive 8. Bring down the plus 12 at the very end. So then we move from left to right. Negative 4 plus 8, that's 4. 4 plus 12, that is 16. So the vertex is negative 2, comma 16, and that's our most important point. Now, since we know they're going to ask us to graph, we might as well plot that vertex at negative 2, 16. So negative 2 on the x. So when we go to the coordinate negative 2, on the back they do go on the x's by 1, and on the y's they go by 2. So we're going to go negative 2 on the x, 16 on the y. Negative 2 on the x, 16 on the y. Let's all put a dot right here at negative 2, 16. This is our most important point. After drawing that most important point, the vertex, we draw an axis of symmetry going right through it. And we're going to label that axis of symmetry because they asked for it anyway. The axis of symmetry is x equals the x value of your vertex, which happens to be negative 2. So this is the A of S equation. The axis of symmetry equation is x equals negative 2. So let's go back to the instructions. Let's see that we're answering everything they want us to answer. They want us to find the y-intercept. Okay, we already knew that by setting x equal to 0. That was our c value. It says the equation of the axis of symmetry. This is what we just did right now. We wrote the equation of the axis of symmetry. It's simply x equals the x value of your vertex. And they also want the x value of the vertex. Well, duh, we already got that using the formula. Okay? So we have everything they asked for in part A. Part B, make a table of values that includes the vertex. Okay, so they would like us to make an input-output table. I usually go with an XY table, and I usually draw it like this, vertically, up and down. Okay? Now they want us to include the vertex x value. What was our vertex x value? Negative 2. Okay, and we also got the y value of 16. So when you input negative 2, you get out of 16. Now they want us to plug in 2 more x values to get out 2 more y values to get 2 coordinates to be able to map them to the other side of this axis of symmetry. So which 2 x values would be good to plug into this xy table? 0 and 0 is great for sure. Now, when we say plug in 2 more numbers, you want those 2 values to be on the same side of the axis of symmetry. Okay, so if I pick 0, which is obviously on the right, I also want to pick -1, which is on the right. Yeah? So let's plug in a 0 and a -1. Plugging in 0 is cake. We already know that that would give us the C value. That's actually our Y-intercept. So you could even label this Y-intercept is 0, 12. And that would be right here. Okay? And if we plug in -1, plug in -1 to see what our output will be. Let's actually show that work over here on the side. What I want to do is rewrite this entire equation, quadratic trinomial, and I'm going to put parentheses in place of x, and I'm going to plug in the -1 into the x positions right there. So again, plugging in -1 right in there, -1, -1. You're going to do exponents first. -1 squared is 1, but of course it has a negative right in front. Multiply -4 times -1, that's +4. Bring down the plus 12. And from left to right, combine -1 plus 4, that's 3. 3 plus 12, that's 15. So the input of -1 gave us the output of 15. So -1 on the x and 15 on the y, which would be right there. Now, of course, you'd have to map them over to the other side, right there, over here, and you have your parabola. Now, what's the alternative to using an input-output table? What was that? The parent graph pattern that we could use, right? The 1, 1, 2, 4, 3, 9. The A value is negative, so all you need to know is that it's opening down. So you could go 1 over, 1 down, 2 over, 4 down, right? Now, this looks weird because the Y values, you have to remember that we're going by 2 units. So when I go 1 over, 1 down, that's really halfway. So right here, 1 over, 1 down, okay? So this parabola is not visually accurate, right? It should look a little bit narrower if you actually had the same units on the x and on the y. But anyways, if you go back to the vertex and you go 2 over, 4 down, 2, 4, right? You can even go back to the vertex and go, again, this is using the pattern 1, 1, 2, 4, 3, 9. So again, 1 over, 1 down, 2 over, 2, 4 down. Go back to the vertex, 3 over, 1, 2, 3, 9 down, 2, 4, 6, 8, 9 would be right there halfway at the y value of 7. So halfway down right there at the y value of 7. So that way you could extend it even further, put arrows on it, map it over to the other side. 1, 2, 3 units away, 1, 2, 3 units away right here. So I did both the XY table that they asked for, and I did also the pattern. Now remember, when using input-output table, you get actual coordinates, actual locations on the XY plane. This is a location, -2, 16. -2 on the X, 16 on the Y, right? 0, 12, 0 on the X, 12 on the Y. -1, 15, -1 on the X, 15 on the Y. These are actual locations when you use an input-output table. They're actual coordinates. If you're using the pattern, it's a pattern from the vertex, but be careful with going by 2 units on the Y's, all right? So make sure you use that pattern accordingly. And that's about it. The middle section, it's really easy. They want you to state whether each one is a maximum or a minimum value. So for example, let's go for number 9, probably the hardest one. Is that a maximum or a minimum value? Well, the A value, is it positive or negative?
Negative.
It's negative, which means what? It opens up or down?
Down.
It opens down. So it's going to be something like this, right? So what is that going to be, a maximum or a minimum? It's going to be a maximum. Okay. Now, so we're going to state the max is, and we need to give an answer, because it says first state whether it's a maximum or minimum, and then say what it is. So how am I going to find this maximum height of this parabola? Finding the vertex. So how would I find this vertex? Yep, the vertex formula, x equals -b over 2a. Use parentheses instead of b and a. Identify your b and your a. The b value is 8. The a value is -2/3. What do we have? We have a -8 divided by 2 times 2, right? If you just put the 2 over 1, multiply 2 times 2, that'll be a 4. 1 times 3, that'll be a 3. And of course, a positive times a negative will be a negative. Now, that looks confusing because it's written vertically. Let's write it horizontally. Let's write it as negative 8 with the division symbol and then negative 4/3 right next to it. And we should all know that dividing by a fraction is really changing it to multiplication and flipping the second fraction. So that's going to become a negative 3/4 instead of a negative 4/3. The negative 8 just comes down. It stays exactly the way it is. Put that 8 over a 1, multiply top with the top, bottom with the bottom, and then reduce. And of course, a negative times a negative is a positive. 8 times 3 is 24. 1 times 4 is 4. So your x value is 6. 24 divided by 4 is 6. Now that's barely the x value of our vertex. What are we looking for? For the maximum or minimum value, which is shown to us through the y value of our vertex. So far we have our x value being 6 of our vertex, and we still need the y value. So how are we going to figure that out? By plugging the 6 into the x here and into the x over here. So rewrite this whole thing, but with parentheses instead of x's. There it is. And let's plug in the 6 right in there. 6, 6. And let's do some math. Exponents first. 6 squared is 36. So I already have negative 2/3 times 36 plus, might as well multiply 8 times 6 is 48 minus 24 at the very end. You could, if you wanted to, multiply 36 times 2 and then divide by 3. Or you could see the 36 up on top and the 3 on the bottom and divide already and then multiply second. So 36 divided by 3, that's really a 12. So you really have a negative 2 times positive 12. That's really a negative 24 plus 48, take away 24. So negative 24 plus 48, that's 24. And then 24 take away 24, that would be 0. So the max value is 0. So 6, 0 is the maximum value. That is the vertex. So that does sound weird that the max value is 0, but all that really means is visually, if I were to have graphed it, the vertex we said was at 0, 6, right? No, 6, 0. So 6, 0 would be 1, 2, 3, 4, 5, 6, 0. So this is the max value. That just means that your parabola opens down from that point. So we've stated the max value, we stated what it is, but they also ask us to state the domain and range. The domain is x equals all real numbers. That's always true for any parabola. The range are your y values. And we know that this has a max y value of 0 and it's below 0. So we're going to say y is less than or equal to 0. So there it is. I've stated everything that I need to state on f of x function, or everything they ask, because there's a lot more that could be said about this parabola. But that's all that they asked for on the instructions. Do the rest, please.